Thank you. Next speaker is David Martens, professor from the University of Antwerp and also proud father of a new big data science startup.
All right, good afternoon, everybody. My name is David Martens, and I'll be talking about the use of predictive modeling with big data and whether having more data, bigger data, whether that's actually better. So I'm a professor at the University of Antwerp, where I had the Applied Data Mining Research Group. So forgive me my academic slides. I'm also co-founder of PrettyCube, where we work in this area. So first of all, what is big data? Well, it's a hype. I think it's very well summarized by this scene from Pulp Fiction. So we better listen to Samuel L. Jackson and be more clear what we're actually talking about. So here we're talking about fine-grained behavioral data. So think of payment data, about location data, website visitation data, all these kinds of data that tells you a lot about your behavior, about all the actions that you're taking. So how does this differ from traditional data, like social demographic? Well, if you put it in a typical matrix form, you see that the transactional data has a huge number of dimensions, way more than with the typical kind of data sets, and it's also extremely sparse. So with this application I will talk about for response modeling, it's based on payment data, something we did with a bank. Each row is a customer and each possible account that you can pay to is a column. So here you have millions of different columns. But of course you paid only to a few of them, so it's very, very sparse. So let's first look at the traditional data, and here you see a graph where on the y-axis you have the predictive performance, and on the x-axis you have an increasing number of training data. So going from a couple of thousand to using the data of about 1 million customers. So you see with traditional data it's pretty flat, which makes sense and which is why sampling is common practice in industry, where you just take a couple of thousand of customers, you build your model on that, and that's your predictive model. Now let's look at what happens when we use payment data itself, the fine-grained payment data. And there we see that as more and more payment data is added to the predictive model, is used as training data, the performance keeps on rising. And we see that for 2 different products, so 2 different response models. And the nice thing as well is to see that it doesn't stop. So this really has an implication that banks, large banks, having more data, have a competitive advantage because they are able to build better predictive models, simply by having more fine-grained data. So such data is available in numerous different applications. I will not go over it, but you probably heard about using Facebook likes to predict stuff, using your Wi-Fi logins, your locations that you visited to predict which ad you're interested in, and so on. If you're interested in knowing about the online advertising part, that's something where our CTO, Dieter, will talk about in half an hour, I guess. We also worked on this topic together with the government for fraud detection, where we used payment data to predict which companies are fraudulent. If you're interested in that, I can refer you to the paper that we presented at KDD last summer in New York. And then briefly, we did all these experiments in 9 different areas with very different data sets, but all behavioral data sets. So this is data about Yahoo, which movies you like. It's data from the bank, like with payment data and all that kind of data. On the x-axis again, how much data do you use to build your predictive model? And you see that the more data you add, the better your predictive models become. Even if you have millions of data, the predictive performance still increases. So there's also a question, to what extent can we keep on being more and more accurate? It is a log scale, so it doesn't keep increasing as well. So the take-home message from this talk is that including more data really helps you to build more predictive models, but only for this specific type of data, so fine-grained behavioral data. It's not for traditional data. And also, of course, you should be able to use that kind of data within your predictive models. And that's where we, the data scientists, of course, come in. Thank you.